After designing the filtration system and testing the sensors, I realized it was time to simplify the wiring with a PCB. In this video, I'll review the control board design, explain how it works, and show you how I stop some unexpected circuit issues. Hi, welcome to Slow Engineering. I'm David. The control board integrates all filtration system functions and includes a PWM signal conversion feature. At first, I control the fan driver and sensors using a breadboard. The sensor functionality worked well in my previous test with ABX extrusion inside the 3D printer enclosure. These sensors, along with a display, use I2C communication with an ESP32 board to monitor the air quality at both the inlet and outlet of the filtration system. The filtration system requires a fan to generate airflow. I chose a 70-40 blower fan because it can handle the high pressure difference between the inlet and the outlet. This fan comes with a driver that allows speed control using a potentiometer. According to the product page, it can be directly controlled by the 3D printer mainboard using a PWM signal. That seems convenient, so I didn't pay much attention to the details. Later, I realized I had made a mistake. I'll explain what went wrong and how I fixed it. If you've been following this project, you'll know the filtration system isn't replacing an exhaust fan. After a print finishes, the enclosure needs to be fully vented to remove any remaining VOCs or fine particles before opening the door. In my setup, I use a 140mm exhaust fan mounted at the top of the enclosure. Here's the problem: the mainboard of the 3D printer cannot control the PWM fan properly because the PWM frequency is different. My mainboard outputs 100Hz PWM, while the fan requires 25kHz for proper speed control. To stop this, I modified the control board. I added an ESP32 which converts the 100Hz PWM signal into 25kHz signals, making the fans work correctly. I also designed the PCB to support 4 extra fans, 2 12V and 2 5V. All of them run on 5V 25kHz PWM signals for consistent speed control. Connect the negative pins on the 3D printer mainboard to the PWM signal inputs to control the fans. Another issue appeared: the PWM signals from the 3D printer mainboard had no proper ground reference to the control board, making it impossible for the ESP32 to read them correctly. To fix this, I added a pull-down resistor to ensure a stable ground reference and to lower the voltage to 3.3V, allowing the ESP32 to interpret the signal correctly. After reading the signal, the ESP32 generates a new 25kHz PWM output, but since it's a 3.3V signal, it isn't strong enough for the fan. To stop this, I use a level shifter to raise the output voltage from 3.3V to 5V, ensuring proper fan operation. At this point, I saw everything was working, but after reviewing the prototype PCB, I noticed another issue. The fan driver's power ground and speed control ground is internally connected. This meant I couldn't directly connect the PWM signals from the 3D printer mainboard to the fan driver because the reference voltage didn't match. To fix this, I redesigned the control board with a steering circuit. This allows the potentiometers and the 3D printer mainboard PWM control to work independently. Since the fan drivers operate on voltage control, It can now accept the 100Hz signal directly from the 3D printer when using the PWM control option. Be cautious that only one can be used here, the potentiometer or the PWM signal. I also added two MOSFETs to ship the 3.3V logic clinic signal ups to 5V, ensuring reliable operation. With this final design, the PWM signals from the 3D printer now only need a negative pin to transmit the duty cycle, while the positive pin provides a steady 5V supply. Everything worked as expected after testing the control board with an oscilloscope and a fan driver. The control board now correctly interfaces with the 3D printer mainboard, which is configured using Clipper firmware to send PWM signals. The frequency conversion function is primarily for fans that require high-frequency PWM signals, not just for exhaust fans but also for any fan that requires precise speed control. In the next episode, I'll assemble everything and install the control board inside the filtration system. What do you think about this design? As always, thanks for watching and moving forward.